Okay, I'd like to go through something called equality of complex numbers here, and I've got a couple of examples I want to go through. So the idea of equality is that the real parts are going to be equal to each other, and separately the imaginary parts are going to be equal to each other. So I'm going to go through two examples to explain this. So if I look at this as a problem, I'm being asked to work out what x and y is. Okay, so if I look at this, I need to tie this up. There's brackets here, so let's open the brackets. So the 2 is multiplied by the x, and the 2 is multiplied by the I. Now, separately, I've got nothing else I need to organize. There's a 1 there, and there's a yi. On the right-hand side, there's nothing to organize. So that's nice. Okay, so let's look at this carefully. I've got real numbers, so there's bits that don't have i's connected to it. Okay, on the left-hand side, and I've got real numbers, the bits that don't have i's, on the right-hand side. So I can say those things are equal, i.e., the ones on the left-hand side must be equal to the ones on the right-hand side. The real parts on the left must equal the real parts on the right. So it shouldn't take you too long by taking away 1 and dividing by 2, we find out that x is equal to 1. Now, separate to that, we've got the imaginary parts. So what have we got here? We've got an I term here, we've got an I term here. That's on the left-hand side. On the right-hand side, we have an I term there. So we can say that 2 lots of I and y lots of I is equal to 6 lots of I. Take away 2 from both sides, and we find out that y is equal to 4. So x is 1, y is equal to 4. The key thing is you're tidying up what you've got to get rid of any brackets, and then you're looking at the real parts on either side and separately the imaginary parts on either side. Let's go through another question. So this one's a bit different. It hasn't got like x and y's. It's just got z, but we're told that z is a complex number. So the only thing you have to realize initially is that z is of a complex number format. So that's a plus bi. It's a real part and imaginary part. Now we're adding on 1 minus 5i. Now on the right hand side, I need to do a bit of multiplying out. So 1 times 3, 1 times 4i, and then 2i times by 3, and 2i times by 4i. It gives me 8i squared. Okay, so just to remind you, so I'm multiplying each term by every term in the second bracket. So if you remember, I squared is minus 1. So this is going to become minus 8. So on the right hand side, I've got 3 and I've got minus 8. That there is minus 8. And these two I terms add together to make 10i. On the left hand side, I need to do a bit of tidying up. 3 times a and 3 times bi. And I've still got the 1 and the 5i. So I've got rid of all brackets now. Okay, the bits that don't have i's in them are those ones and those ones. So I can say to myself that 3a plus 1 is equal to, well, it's minus 5, isn't it? 3 take away 8. Take away 1 from both sides. Divide by 3. I find out that a is minus 2. Then looking at the I terms, the imaginary terms, I've got those two on the left hand side and I've got that one on the right hand side. So I've got 3b minus 5. Where did I get that 3b minus 5 from? I've got 3b lots of I and I've got minus 5 lots of I. I'm not bothering to write the i's basically in waste of ink. Okay, I'm just looking at how many i's have I got. And on the right hand side, I've got 10. So if I add 5 to both sides and divide by 3, I end up with, right, my mistake there, 15 divided by 3 is 5. So I know this z that I started off with, which is a plus bi, okay, is minus 2, that's my a value, and the b is 5. So z is equal to minus 2 plus 5i. So again, I was tidying up, opening brackets, and then saying to myself, what are the real parts? Equate them, and separately, what are the imaginary parts? Equate them. And each of them gave me one of the answers I was looking for.